Hi everybody, welcome to HackerEarth webinar series. So this webinar is about Internet of Things. So let me tell a short introduction about myself. So here it's Aravindhan GK. So I'm a developer and solution engineer and I work for IBM Internet of Things. Okay. So primarily my work will be about solutioning Internet of Things platform for multitudes of industries, ranging from electronics to industries. So there is the reason buzz about Internet of Things. So I thought, why not give a webinar with HackerEarth about Internet of Things to the general public to make them understand what Internet of Things is and make them relate it with a real life scenario, that is connected cars. So this is the agenda for this webinar, and let's get started. Okay, as we know, let's start with the basic introduction. What is Internet of Things? So we know Internet has been around this world quite a couple of decades or earlier. So Internet, we mean connecting computers together for sharing data, for sharing information, and to interact with people around the world. So this is how Internet has begun. And then we had conventional things which we can just use in our day-to-day activities, like say a chair, a table, and an electric bulb and AC. So these are our conventional things. So as Internet evolved, people thought about making these things smarter. That is, how to make these things smarter, to connect these things, share information between these things, gather data out of it, and then gather more insight out of it to achieve more out of all the conventional devices. So the diagram describes that we had our Internet and we had our things. So connecting the things to our Internet makes Internet of Things. So the conventional definition goes as this. The Internet of Things is the network of physical objects or things embedded with electronics. Say you have a chair in your home that will sense how heavy are you, and say whether you have to reduce your dietary or you have to maintain it, or what kind of physical activity you have to do. So your chair will be embedded with some kind of electronics and some kind of computing power, so that it can connect to your phone and say that, hey buddy, you have been sitting for more than 2 hours, just move and then make some physical activity so that you can burn your calories. So this is a simple example of Internet of Things. Hope this clears. Let's go ahead. So when we think about Internet of Things, we will say, isn't it already there? Okay, so let me give a differentiation. When people get into office, they swipe their RFID card. So RFID reader there is a thing, and the door at the entrance is a thing. So in the conventional model, our RFID tag is sensed by the reader. Our data is sent to the backbone server, and the backbone server validates it, and it sends a command to the door saying the door to open. So this is the centralized traditional control application which you see on the left. So when we come to Internet of Things model, the architecture is further modularized. That is, the things can communicate with each other directly and to the backbone server. So it has its ability and it has computing power so that it can interact among itself, and at the same time it can send data to the centralized server, that is the Internet. Okay, so when comparing the conventional RFID to Internet of Things model, what will happen is that the RFID reader will have certain amount of computing power and memory capacity, so that when you enter the gate each and every day, what happens is that it will identify your pattern of entry. So, okay, say Arvind is entering this building at 8 o'clock in the morning. So what will happen is that at 7 o'clock, there will be a set of data that will be loaded to the RFID reader. So when I come at 8 and swipe my badge, so it will see that local file and say, yes, this user is already present, and it will directly send the data to the door saying it to open. So this is the major difference between what is already existing and what is Internet of Things model. That is, the devices can communicate among each other without the necessity to going to the central cloud and coming back. So this kind of architecture is also called as machine-to-machine communication. So Internet of Things and machine-to-machine go hand in hand. The only difference will be when we connect things to Internet, it can communicate to enterprise level applications, say SAP, Maximo Asset Management, or any resource management applications, or any customer interaction applications. Say, for example, if there is a problem in your device, it can directly communicate to your customer service and book an appointment for you stating this guy is experiencing some issue with our product, so that your service person can go away directly and attend it without customer being communicating to your service desk. So this is a basic example of Internet of Things and how it differs from the conventional architecture. Okay, so why IoT now? Internet of Things is already, I would say it's an explosion of Internet, and it's an explosion of things, smart things there around the world. So everybody of us will have a smartphone, and everybody of us will have at least 3 gadgets connected to the Internet. And Cisco's survey says that we have already more devices, more connected devices than people. So by 2020, it is being expected that there will be 50 billion devices. That is almost 5 times of 5 times the amount of people on this earth. So when things get smart, it means that it is getting connected to Internet, and that comes an evolution of Internet of Things, that is explosion of Internet of Things. Okay, so let me relate it with an illustration, that is connected cars. Say what happens in an existing car, you should always go to your regular maintenance service and then check, okay, whether all the parameters, say engine oil, the brake fluid, so everything are fine. And one fine day when you're on your way to office, if it goes down, that is, if your car breaks down, then you'll spend your time wasting, oh, what to do? You'll call the customer service there, or you'll book an appointment for a car to be serviced, and then you should take it there. That is, you're wasting hell a lot of time in this process. So how can this be neglected with Internet of Things? Okay, so what will happen is that your car will have sensors connected to it. Say it will pick up your tire pressure, it will pick up your brake fluid, it will pick up your engine performance, and what it will do is that it will analyze and say how your car is performing. If there is some kind of possibility of malfunctioning, it will directly communicate to the Internet and to your service center stating that, hey, I'm experiencing some trouble. So please book me an appointment. And then what it will do is that it will send a message to you stating, say, I have booked the appointment at this time, so you can drop me and go to office. So what happens now is that by introducing Internet of Things, we are eliminating the user interaction with the car. That is, we are eliminating the troubles which we will. Yeah. So we are eliminating user interaction with the car, and then the car can directly communicate to the service center requesting a service. So I guess this will clear you down. Okay, so how do you realize Internet of Things solutions? Okay, so we will be having conventional devices, and we will be having conventional web applications, enterprise level applications connected to the Internet. So previously there will be computers, that is, we call them clients, connected to the Internet. They will request for service, they will request for information, and your server will provide it back. But now when it comes to Internet of Things, the major thing is that there should be redundant connectivity, and the message packet should be so small that it doesn't eat your bill. That is, it doesn't eat your data rate, and it doesn't eat your bill. So to achieve this, we resort to another protocol called MQTT, that is Messaging Queue Telemetry Transfer. So our devices, that is the conventional devices, in this case the sensors fitted to a car will communicate to something called as IoT broker, which is the centralized message handling platform. The devices can communicate to the broker, and our applications can directly communicate to the broker and then get data about the devices and do some analysis and carry ahead with the conventional process. Okay, so let us see more about MQTT in further going slides. So MQTT has two modes of communication, that is publish and subscribe. So let's go ahead and next slide about it. So to realize any IoT solution, what we require is the central platform, that is the MQTT broker. To relate it with conventional web architecture, this is like server, but the difference will be it can just transform the message. It can just transfer the message from one end to the other. That is, it acts as a broker. That is, the device will send a message, and this broker will in turn pass this message to all the applications which are requiring that message. So that is the difference between an MQTT broker and the server. Okay, let's get to know more about MQTT. MQTT stands for Messaging Queue Telemetry Transfer. Okay, what is this MQTT and why do we need it now? So we had HTTP, we had TCP, which is the base layer on which we have a lot of, we can use UDP, and why do we need MQTT for Internet of Things applications? Okay, MQTT stands for Messaging Queue Telemetry Transfer, widely used for machine-to-machine communication. Okay, so it was invented by Andy Stanford Clark at IBM, and it is now open source to Eclipse PAHO. So Eclipse PAHO is a group which developed the standards of MQTT and developed client libraries, that is, they maintain MQTT as a whole. So I have provided the link there stating where we can find the MQTT libraries. So we have to go to eclipsearch.paho where there are various client libraries available. So what will happen now is that you will put this MQTT client libraries inside your devices, so, and then you write a code snippet so that your devices will collect data from the sensor and push it to the broker. So these client libraries perform a major role in your device. So when it comes to your, say for example, you have a conventional device running with a Java virtual machine on it, then you'll take the MQTT Java library available here and modify it according to your requirement, put it on your device, read the sensor values connected to the device, and then push it to Bluemix. So this is how the left end of IoT architecture works. Okay, so let's see what are the advantages of using MQTT. MQTT, as I said, is lightweight, publish and subscribe messaging protocol. Okay, so MQTT is not so new. It is used around all the, it is used by most of the messengers available now. So MQTT is optimized for mobile and push capabilities. So let me describe what is it in more. MQTT is designed for low latency, assured messaging, and efficient distribution. HTTP is designed as a request response protocol in contrast with MQTT, and it will be used for client-server computing. So when we see the packet structure of MQTT, it is very lightweight when compared to HTTP. So the major advantage of this is most of the devices will be relying on a battery to operate. So when we put it into conventional HTTP, there will be a lot of battery energy which will be eating out, and so we use this MQTT protocol. Now that MQTT is lightweight, the packet size will be reduced, and then the battery energy which will be required to transmit it will be reduced. So that's why most of the IoT platform will stick to this MQTT as a protocol at the back, as a backbone protocol. Okay, so let us go back to the previous slide. That is, how do you realize it? Now that you know your device has MQTT clients and your IoT broker service that it can listen MQTT messages. So what do you know? How do we connect to applications? This is the next point. Okay, so let me say more about MQTT. Like I have said in the second point, I have said MQTT is designed for low latency and assured messaging. And now let me describe how messages, that is message delivery or message transaction is being assured in MQTT. Okay, so MQTT has a parameter called quality of service. We call it as QoS. Okay, so this QoS will ensure that your messages are being delivered at various rates. Okay, so let us take QoS 0, that is at most once. Okay, so when you in MQTT messages, when you're providing MQTT messages to the broker, this quality of service will be sent along with the packet. Okay, when you set the quality of service to 0, what it says is that it is fire and forget mode. That is, it will just send the message to the broker and it will not take care whether the message has been successfully obtained by the broker, it has been transferred to an application, or it has been processed. So it is called as fire and forget mode. So this kind of mode can be used for monitoring applications. Say for example, you have your car and you have a mobile application. So what you need to do is that you just need to see, okay, at any point of time when you take your mobile application, and then you can just monitor what is my tire pressure, what is the fuel level of my car. So for those kind of applications, you can use QoS 0. That is, when a packet is missed, there is no great deal about it. So you can always request another packet, that is another data from the sensor, and see, okay, what is your what is the level of all the parameters of your car. Okay, so that is QoS 0. And we use QoS 1 to say at least once. It means that there can be duplication of messages. So we use this kind of quality of service to ensure that your messages are delivered for sure. And when there is no problem of message duplication, or when you use QoS 1, the quality of service 1, there should be some kind of mechanism at the application side so as to handle the duplicate messages. Okay, and next we have quality of service 2. So when we use quality of service 2, it will ensure that your messages are reaching the endpoint. That is, it will have a publish and acknowledge, it will have a handshake kind of mechanism. So when the application gets your messages, it will send back to the broker, will send the command back to the device saying, yeah, the application has successfully received the message, you can stop transmitting now. So this is quality of service 2. Okay, by these 3 quality of services, we are ensuring message delivery using MQTT. So when it comes to IoT, the 2 major questions here are about the security, and the second thing is about message latency, and then about message latency, and then about message losses. So when we resort to MQTT, and then when we are using QoS 2, we are addressing that there is no message loss. And then for security, the IoT platform has transport layer security, which will ensure the data is secure and being transported to the intended users. So I would say IoT is evolved IoT is evolved rather than considering about the security and message reliability. Okay, so we have some questions. Okay, so the second question is, can MQTT run on devices very small memory footprint? Yes, it can. And a device that runs MQTT requires TCP/IP. Yes, MQTT is a layer over TCP/IP. You can relate it like you are just replacing the HTTP protocol with this protocol so that it runs on low battery. What are the other publish subscribe alternatives? Yeah, some are there. Security in transport layer, does it mean that the data is sent as encrypted? Yes, you can encrypt the data and send. Okay, so we will take more number of questions at the last. Okay, so let me go back, realizing IoT. Now that you're clear about connecting devices to IoT platform, what an IoT platform is, and let us go into actualizing a solution. Okay, so this diagram describes how to actualize an IoT solution. So the central bone of IoT will be the platform, that is IBM Internet of Things Foundation, which I'm using for this webinar series. We have our devices, say it can be Arduino, it can be Raspberry Pi, or it can be any kind of custom developed board according to a requirement. The custom developed board will be having a firmware which will be running either C or a Linux kernel or say a JavaScript even. So you can take the corresponding MQTT libraries from Eclipse Paho, that is I'm saying at this part. So you can take the corresponding MQTT libraries from Eclipse Paho and incorporate it into your code and then push data from here. So that is the leftmost part of an IoT solution. And then once the messages are or with the MQTT format, it can be pushed to the IoT platform. So in our case, this is IBM Internet of Things Foundation. Okay, and this Internet of Things platform is in cloud. So any application can straight away access it through API calls. So it can be either OAuth mechanism or a token-based mechanism, any kind of secure mechanism you can use at the right-hand side of your IoT solution, connect to the platform, get data, and then do your and then incorporate it with any enterprise application or use it for any analysis and get more insight out of it. Yes, this is clear. Okay, so let's go about actualizing it. As I said, the broker, the message broker which we are going to use here is the Watson IoT platform, that is IBM's IoT Foundation, and the application server will be the cloud platform, IBM Bluemix. So for this webinar, I will be using a simulated car, that is the parameters of a car, say the tire pressures, the battery, the fuel level, and the geo values, lat long values will be simulated from a web-based application, and this data will be pushed to the IoT platform. Okay, once the data is available on the IoT platform, I'll be using IBM Bluemix as a cloud platform to get data and host. So the application which is hosted there will collect data, and let's discuss what it does further. Okay, let's quickly jump into the live demo. Okay, let me give a brief introduction about IBM Bluemix. IBM Bluemix is PaaS in simple, that is platform as a service. So saying Bluemix as platform as a service, we'll be having server spaces, server runtimes, database services, analytics services, all hosted on the cloud and provided to you for as a service. Okay, so let's scroll down and show you what are all the services available. When you see here, there are a lot of runtimes available for you to host your application of choice. Say you want to choose Java, you can run here. Node.js, you can run. So when you see all the top runtimes are available here, so you can host your services in the application of your choice, in the language of your choice. And you have empty containers. These are just storage spaces to use. Next, we have Watson services. Watson is used for cognitive computing. So all the Watson cognitive computing APIs are available as services here. You can make REST calls from your application and consume those services on your application. So we have mobile. So let's get into IoT there. So these are the Internet of Things services available on IBM Bluemix. So the core thing will be IBM Internet of Things platform. So they have modified it for IoT for electronics and for automotive. There are a lot of services built on top of Internet of Things platform. So we will be using this Internet of Things platform for our application now. And then we have a lot of data and analytics services. We have Apache Spark which can run on it, Cloudent, DashDB. So you can use all sorts of any sort of database, any sort of application runtime and language, and build a full-fledged application on Bluemix. So this is the platform which we are going to use to develop the application. So to log into Bluemix, you can go to this link console.ng.bluemix.net, and then you can register yourself. You'll get a month of free time so that you can experiment stuff on it. Okay, so now we are conversant with what is Bluemix. So boilerplates are starter applications which will have services clubbed together. So this IoT starter application will have the Internet of Things platform, a Node.js runtime, and a Cloudent database clubbed to it. So you can choose this one to take the service, and then you can build your IoT application on the server. Okay. So as I said, by using the IoT starter application, I have created this connected car monitor application. And this connected car simulator is the simulator which we are going to use. So it runs on Node.js. So let me just open and show how the simulator looks like, and we'll see how it is being coded there. Okay, so this simulator will send the live tire pressures from all the 4 tires, the battery level of the car, the fuel level of the car, and you can accelerate, decelerate. So consider this application as a real car, and a device is being plugged into it. So in a car there is a port called OBD, onboard device. So these are available in almost all the cars, and when you take it to a service center, say a mechanical garage, so they will plug the computer into it and they will tune its performances. That is the engine performance. They will analyze a lot of things when you take it to a garage there. So that port, we are tapping it and we are putting an external device over it so that it will send data to the cloud. So for simulation, what I will do is that I will considering this simulator as a real device, I will plug the JavaScript code into the simulator and collect data out of it and then send it to the cloud. Okay. So this application is hosted on Bluemix. So the code is available there. I'll get into the Git repository and walk you through the code quickly. Okay, so this is the repository, Git repository for that connected cast. So this runs with Node.js, and let me take the index.html. That is the page which you have seen there. Okay. Okay. So this is the basic web application. That is, this page is the index.html page, and considering this page as a device, I'll tap data out of this page using the JavaScript plugin. If you're going to port this to a real device, it will be a C, that is Eclipse Pacos C library or a Java library, which you'll be plugging it into your real device. Okay, so these are basic HTML code where you see the forms are being created here. So at the end of this code, I'll be importing 3 modules. When you see here, at the end I'll be importing 3 modules. One is MQTT WS331. So this is the Eclipse Paho JavaScript library, which is being hosted at the, which is being developed and maintained by Eclipse Paho group. And this device.js is a wrapper around the MQTT library, and this publish.js will extract the data from this page and push it to the cloud. So let me get into the code level. So there is this MQTT WS31. So as you see, this has been developed by IBM and given to Eclipse Paho. This is the core MQTT library, which will encode your data to MQTT protocol and send it over to the internet. That is the IoT platform. Now let me go into device.js. So this device.js is a wrapper around that MQTT library, that is MQTT.js. So it will provide what is the organization ID, what is the device ID, what is the token by which it should connect to the platform. Okay. So at this point, I have to explain you more about an IoT platform. So what's an IoT platform? So let me jump there and then I'll get back here again. Okay. So an IoT platform is a server, is a message broker which can take care of device management, device registration, data transfer, and device related activities such as firmware upgradation, over the air commands, sending commands to the devices. So all these are functions of an IoT platform. So the main thing for any IoT platform should be device management, that is registering a device and associating devices to users and to organization. Okay, so when you register yourself on any IoT platform, you will be provided with an organization ID. Just a minute, I'll highlight it there. So you will be provided with an organization ID. So this organization ID is a unique ID that will be provided. That is, it is like creating a space for you on the platform and providing the space to you based on this ID. So under each ID, there cannot be any duplication of device IDs. So that is under a platform there can be as many number of organizations, but under each organization there cannot be two devices with same device ID. So this device ID is like a unique identifier for each and every device. Before a device can connect to IoT platform, it should be registered on the platform stating that this is an authentic device to connect to the platform and send data to the platform. So I have already registered a device there, stating it as car, the type as car, and let's see what the device is. On the left, when you go, you will get the devices list, and it says the device ID is car and the type is car. So to add a new device, you can click on the device there, choose a type. If you want to create a new type, you can create a device type here. Click on next. So it will ask for a device ID. So, and in this metadata, you can give data about the device. That is, who is the owner of this device, what is the SIM card type it is using, what is the firmware version it is using in. So those kinds of data will go here. So let me close this page just for a demo. I came here. Okay. So these device registrations can be even done with the HTTP API. You can create an application. You need not come into this dashboard, come into this website and then do it. You can create an API, connect using HTTP protocol here, and then register devices. Once a device is registered, you will be provided with an authentication token. That token should be again pushed back to the device so that the device can send data to the platform. Now that I have a device named car registered, I got an authentication token while registering it, and that is the device token which I am putting here. So this is something like certificate transfer, that is the public key private key match which we do in the conventional web application. So when a device connects to the platform, it will send this token, the token will authenticate, and then the device can send data to the platform. Okay, so I'm connecting the device here with an organization ID. I'm saying which is the organization ID to use, what is the device type, what is the device ID, and what is the token. And after going there, I'm connecting to the host, that the endpoint, that is the host will be orgid.message.internet.things.cloud. So this host name is the endpoint which any device will connect to. So when you see here in the conventional M2M application, that is the machine-to-machine application, there was a necessity of static IPs on the device side. But on the Internet of Things platform, now that the devices are put on internet, they can have public IPs, and with this device ID and organization, by this tenant architecture, we can straight away go and access any device. We can send commands to the device and make a firmware upgradation. So a whole lot of things are possible there. Okay. Once the device is connecting to the IoT platform, it should validate itself with this format, the org ID device type. So what I'm saying is that this will be the JavaScript file for this website to get connected to the Internet of Things platform. Similarly, you will be writing a C code as a firmware on your device and put it on your device so that it will connect this device sensors. It will collect data from the device sensor and push that to it. So what happens is that I am defining a lot of parameters. What will be the QoS level? What will be the keep alive time? That is when the data is not there for around say 3 minutes, then it will disconnect the device automatically, and the device has to initiate a connection again. So to add one more thing, MQTT is a sessionful protocol, where HTTP is a sessionless protocol. So once the device is connected, it can continuously send data, and the session will be kept open. That is, the port will be kept open for it to listen to that device. Okay. So I'm saying client.connect. So here it connects to the IoT platform, and it will say on success, it will send a message, okay, I have connected to the client, and then it will start sending. So this is the MQTT protocol. That is, for our device to connect to the platform, we provide the credentials. This JavaScript file, device.js file, will send the credentials with which we'll connect to the platform. Now let me go to publish.js. So publish.js is the file. It runs with jQuery to get data from the web page. So instead, if you're putting it on an Arduino, or if you're putting it on a Raspberry Pi, there will be a Linux kernel running on it. On top of Linux kernel, you can run your Node.js code or your Python code, and this Python code will get into the IO pins, extract the data, and push it to the cloud. I hope this will clear the doubt. Okay, so this will be the difference running on a simulator and running on a real device. So on a real device, this will not be a publish.js file. Instead, it will be like publish.c file in case your firmware is running on C, or a publish.js if it is running in Node.js, or a shell script even to connect to your sensors and then collect data. So when you see here, this snippet, I'm taking the rear right tire pressure. So I'm taking the rear right tire pressure, forming a JSON file, that is forming a JSON object, and then I'm sending data. So this will be the same snippet, but in a different language based on the firmware which we are going to use. Okay, so what it does is that now it goes to send data, and in the send, I'll be defining what is the topic it has to push. So when it comes to IoT message broker, that is the IoT broker, let me go to the presentation back again. Okay, so when you see here, the devices can publish to the broker and subscribe to commands, and the application can subscribe device events or publish commands. So how do you think there will be a flow of data maintained here? So each publish, that is the device publishing data, will be given to the broker with a particular message title. So when a device publishes data, there will be a particular message title it will be pushed to, and the applications should be subscribing for the title. So when a device publishes, say for example, I'm going to publish a device titled event. So there will be application which will be listening to this events. So whenever a device sends whenever a device publishes the data under the title event, all the applications which are subscribed for that event will receive the data. So this is how the data flow happens from a device through the IoT broker and back to the application. So similarly, when it is going to send commands, there will be a particular title which it will publish the command, and then the device in turn subscribes to that title and gets the data back. So this is how the message flow works there. Let me go back to the code again. So here I'm saying this is the topic to which I'm pushing there. So I'm having two topics. When the regular status of the car will be pushed under the title status, and the alerts will be pushed under alert. Okay. So this is how the data is obtained from the HTML page and pushed to IoT cloud. So let us see how to handle the data on the cloud, that is from the application. So this is Node-RED. Node-RED is a pictorial representation of Node.js. That is coding. There will be only minimal level of coding, while we can have easily route the data by the flows as you see. Okay. So when you go back to platform, so this connected car monitor is the application, is the backend application on the server, which will connect to IoT service and save the data to cloud end or do something else. So this runs with Node-RED. Node-RED is a pictorial representation of Node.js. So that is a module available on Node.js. So those who are conversant with Node.js will be knowing about it. So IBM's version of Node-RED is already open, and IBM's version will have all the services on Bluemix embedded here as a node. Okay, so I am pulling out IBM IoT node. So, and I will configure what are the parameters with which it should connect to the platform. So these are function blocks where I can define how the data flow should happen. So I'm defining where the front left pressure should go, where the right left. So this is all for processing the message. Say setting the threshold. Say for example, I should get a message on my mobile when the tire pressure goes lesser than 20 psi. I should get a message, or the service center guy should get an email and book a service whenever there is a fault on your car. So in that case, so to route those functions, we use these flows. Say I have a tire pressure flow which will compare whether the tire pressure is greater than 30 or less than 20. So whenever I have these parameters, it will just send me a message out on my mobile. Okay, so let me just simulate this and show you the data coming in here. So these are called as debug nodes, which will put data out here. So going back to connected car, let me increase my tire pressure over 30. Okay, once I increase the tire pressure over 30, the backend JavaScript file will pick the pressure from here and send it to IoT Foundation here. So you can see I get a parameter front left and the value is 32. So this is how a device will be connected to IoT platform. From the IoT platform, you can extract data through applications. Once we get data from here, there are a whole lot of things possible there. You can either combine it with any cognitive analytics services which are available here, such as Watson Analytics, or you can do some kind of predictive analytics and provide it to a front end. Let me show a front end from which can be used to collect data. So say this front end will be connected to the car, so we can monitor the parameters of our car, where is it on the map, and so these things, it will be available on the internet for you to see anywhere. So what is the real use case of it? Now that you have data on the cloud and data is flowing continuously, and so say for example, so now the data is available on the cloud, it can be used by an insurance guy. Say for example, now that in current scenario, in the current world, we are just paying insurance, say in a yearly basis. Instead, an insurance guy can monitor your brake usage and say, okay, say you're just using your brake so much, so that you can pay insurance only for your brake. No need to pay an entire insurance plan. So those kinds of things are possible. Or this data can also be used by the car manufacturers, and then they can improve the design of the car. So those things are possible when the data is available on the cloud, and you get a continuous stream of data. So so you get a continuous stream of data, and a lot of things can be done by it. So say for example, your car books a service appointment there. The service guy can in turn use the data to allocate the service bay for your car, and then whole lot of things are possible. Yes, this has provided you an overview about IoT, how to connect devices to a platform and then derive value out of it. Okay, so these are some links you can find. It's 8:50 already, so we will listen for some questions and then we'll close this webinar. So you can reach me out at there. So let's get into the question session. Okay, so Bhargav has asked, when do we use QoS1 and QoS2? So as I said, when you're considering your message is not so important, you can use QoS1. And when you say your message should at least once reach the application, then you will use QoS2. Can I run MQTT on Arduino? Yes, of course. On Arduino, if you are using a Linux kernel on Arduino, no. There are C libraries available for Arduino, MQTT libraries, so you can take that from Eclipse Paco and put it there. Can we develop a custom MQTT broker? We have open source MQTT brokers. If you are there is RabbitMQ, HiveMQ, so you can use those brokers. But developing a custom MQTT broker is like building a device for yourself, that is building an enterprise level of device. So that involves a lot of things like message handling, message queuing, load balancing. So those things should be taken into account. Is this simulator available for public users? Yes, this is available. I'll go back to the, I'll share the slide to the public. So you can go to the links there and join my Git repository. You can take the code available, you can take the code from there. So, Rajavel, so in a car, should there be a central device to which various sensors connect to and from there is pushed to the internet? Or should be a sensor independently able to push data to the internet? So in a car, there is, as I said, there is something called as CAN bus, that is controller area network, runs within a car. Say your car has a central lock system, your car has connected doors, so these all are connected through this CAN. They call it as CAN bus. We are just plugging plugging a device into this CAN bus that will take data out of this CAN bus and send it to internet. Can we practice on IBM Bluemix? Yes, you can practice on IBM Bluemix. Kindly suggest some sources for learning about different nodes used in the Node-RED. Node-RED is as such open. If you are registering on Bluemix, when you click on each node, there is a detailed documentation available for it. Can we get the access to view code? Yes, I will share the link with you. Are there any OBD2 connector available for MQTT? No, there are no OBD2 connectors as such available for sending MQTT. There is a device called Golo that runs with Linux. You can put a shell script on top of it, and then it will send MQTT. ESP8266 seems to be in popular IoT development board. Is there an MQTT library? Yes, it is available. I have been recently working with ESP8266. You can run a firmware with C. You can take the C MQTT library from Paho and put onto it. In this demo, what QoS did we use? I used QoS 0, so it is fire and forget. Is this presentation recording available? Yes, it is. I have done project on car automation using Arduino, and it is controlled via Bluetooth. Yeah, so the difference between connecting it via Bluetooth and connecting it to internet is that your car can straight away go and your car can straight away go and make an appointment for service. So when it is experiencing some issue, yeah, it will directly go there. Does Tesla cars have IoT? Yes, it does. So these are the links. I'll share this slide to the public so that you can take these links and join me there. Hope this was a good session. Thank you all for joining. Thanks for HackerEarth hosting this presentation and asking me to take it. So hope we'll all connect together. You can ping me at this email ID. Drop me a mail there, and the queries here can be taken separately by the HackerEarth organizer, and any other query can be dropped to my mail ID. Thank you. Thanks everyone.